Okay. In this video, excuse me, I have something in my throat. Should have probably cleared that before I started the video, but oh, here we go. Yeah, in this video, what we're going to be doing is we're going to be examining this loop here. It is important to note that it is a loop because when we enter here, that will not become apparent instantly. But yeah, we are in a infinite while loop, which means that as long as this continues to evaluate to true, this will continually spin. The reason for this is that this, in essence, basically turns into a um, just a general purpose loop. It'll just have a general purpose thread component to it. Like if you remember from earlier videos, we created a thread pool. Well, this essentially adds the main thread to that thread pool. So what I've done so far was I've removed a number of breakpoints that were utilized for the previous videos, and I've reduced it down to just torque engine tick here. I could have exported it, like if you didn't know this, in Visual Studio you can export a breakpoint set to a file, but I don't think it's sufficiently complex enough to require a breakpoint set, but for your purposes might help. So let's step in here. So we'll step over. Okay, so this is what it does. It calls do main loop and standard main loop. So this is everything that needs to get done. So I'm guessing standard main loop is utilized in a number of places. Hold on, I'm looking here. Oh, I guess it's just once. I think the thread main loops are a little bit different. Don't quote me on that though. But anyway, yeah, it stands to start a standard main loop. If I continue into it, you can see that it's really simple. It's got a check for the startup timer. So here we go. This used to be the loop in itself. Main loop.cpp, this main loop function here, this used to be a while loop. This used to be the entire loop, but it was moved back into torque main. I'm guessing that this is because uh, it's just easier to use if it's not in its own while loop. But so here we set the background threshold, the foreground threshold. I'm not sure exactly what that means. This is something we're gonna have to go back later and look at. I'll set background threshold, set foreground threshold. I mean, it's working off the timer. TM is our class timer. So I guess it's just kind of making sure that processing happens evenly, I guess. So let's step over. So remember that this loop runs constantly. If window manager, get first window. So it tries to get the first window. Let's step. Oh, let's step till return. Step. You can see it does get it. So let's go step over. Last focus, new focus. So it's checking window focus right now. Simple enough. Okay, so after it checks the window focus, platform, get web deployment. So this is for the web plugin, I guess. The Torque 3D web plugin. 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 The Torque 3D w So I guess this is important to note. So do not sleep the process, um, because it'll cripple browser performance. It's only if it loses focus. Interesting. Hmm. I'm gonna have to look at that web plugin because that sounds interesting as all hell. Being able to go to a web page and that web page just basically runs the CS script, I guess. That makes a lot of sense. Because I mean, the CS files are pretty small. I mean, in regards to the entire game. I mean, in regards to a entire game. I guess the only real problem would be transmitting the Collada files and game assets and such. Yeah, cool. That is where I would see abuse as a security professional. Like, you'd be able to use that plugin to gain compromise. Okay, you know what? Never mind. That's off topic. But yeah, okay. So step. So it did set the background, new focus. So if not, get web deployment. So this is what it does if it needs to sleep. This is what it does if it doesn't. So continue or not continue. Step over. So here the profiler started. This is where a frame is calculated, and this is where events are processed. So I think only the main loop processes events. I think that's the difference between this and the threaded loops, because I think process main thread work items. It's in the thread pool. Yeah, there wasn't any different function, because I remember when I was looking at subsystems, a variety of different subsystems, Qt1 in particular, that this was being hit a lot, and I think that the reason that's being hit a lot um, is because they all share the same routine. That's why I said in the beginning of the video that the main thread is basically just another worker thread. It's because of this implementation. Okay. So let's step over. Step over. Oh, I should have stepped into that. This is really simple. Um, it just adds to the current frame delta. I'm not sure what the frame delta is used for, but I do know operator precedence. So this here is evaluated first, and then it's ANDed with this. So if current frame delta is equal to the sampling frequency, and the sampler backend is set, um, it starts sampling. So I guess it captures the frame here if it needs to. I think. Go back. Um, and consecutively, here's the end. Process events, I believe, just processes all device events. So I'm not sure entirely. So process all of the devices. So I guess this is just saying you get all input from all devices that are currently being supplied as engine input. I think. Pretty sure. And I think it'll enter here. Maybe it won't enter there. If not, request shutdown. If it is request shutdown, then request shutdown equals false and return false. So I think it's going to enter here. So let's just stop. Yep. Journal is playing. Return journal play next. So the journal isn't playing. Ooh, I don't really know what a journal is. Not in regards to this. The journaling system record external events and non-deterministic values from an execution run in order that may be replayed for debugging purposes. Oh, okay. The journaling system is integrated into the platform library, though not all platform calls are supported. Oh. Okay, so it's just a debug journal. If it is enabled, then debug journaling will just work automatically. And yeah. Wow, look at that ugly ass code. I mean, I get it, but I guess this is kind of like syscall tracing. Hooey, look at that. Oh, this reminds me of some code I wrote back in 2002. 2003 maybe. Holy shit, that was a decade ago. Okay, so anyway, returning true. Exiting. So now the events should be processed and I guess dispatched through signaling. And here is where we process the main thread work items. This is what we looked at earlier. Should hit this. You know what? I'm not sure if it will hit this. I'm assuming it will. So it'll process one item at a time, so long as they're not over the time limit. So I guess each item has a 6 millisecond time limit. So that's how it actually processes things. So they should each process in faster than 6 milliseconds. Step over, step over, step over. So there is nothing, there was nothing in that case from the main thread queue to process. If not, take next item, break. So it just basically takes an item and then it processes it if the item is available, and if not, it exits. Real simple. It's because of that break is where it actually exits. Okay. So if I step over, I can see that end frame is called. If we step into that, we can see once again frame delta equals sampling frequency and G sampler backend. So step. So if we're recording video, it'll go bam, 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 bam. I think. But here's profiler code if we were using the profiler, which we're not. So let's step over. See here, you can see the end profiler. See return keep running. Keep running is true, which will bring us back to the while loop. Again, engine tick. Remember when I said the callee was a while loop? It was just an endless while loop. Well, this is the second iteration of the while loop. If I hit continue again, you'll see engine tick, continue, engine tick, continue, engine tick. And I could do this for as long as the engine was running, and you would see all the events being processed. And not just that, but you would see the work items being processed as well in this thread. So that's how it works. When the application exits the engine routine, or the engine shutdown routines are called. This is very little interest to me. Once this is happening, the application is shutting down, so memory is being freed throughout the system. I might make a video on this a little bit later. I want to actually start creating my own module at this point. But yeah, that's how I'm going to be going forward with this video series. What I'm going to do is similarly to the WebKit example that I was looking at, I guess, a couple days ago. Similarly to that, like I want to basically create my own module so I can see step by step how to actually do this. And the module I'm going to create is a Torque 3D integration to the Microsoft speech recognition API. So I can start up my application and I can say something in game, and it'll run maybe some script, or it'll run a command or something. But yeah, thought you'd find that interesting. That's it. Goodbye.